Today we're going to talk about Docker. Docker Inc. is the company that makes the software containerization platform called Docker. We're going to talk about the containerization platform, not so much the company. So the way I want to go about this is to introduce the idea of containerization. I'm going to do that using a definition I got from TechTarget, and then we're going to break that definition down because it has a lot of key terms in it that you may or may not be familiar with. Alright, so let's start by defining containerization. It's an OS level virtualization method for deploying and running distributed applications without launching an entire VM for each application. Alright, first term I want to break down in there is virtualization. Virtualization is a way of dividing up a resource logically rather than physically. This concept goes all the way back to the 1960s when mainframe computers were common and we needed a way for many people to share that single source of compute power. At the time it wasn't practical to give everybody their own computer, so we used virtualization to break up that one mega computer and treat it like many smaller computers. So in short, virtualization is taking a single resource and pretending it's many smaller, more or less independent resources. Alright, our next key term in the definition of containerization is distributed applications. Distributed applications are a lot like regular applications, but instead of running on a single system, they run on many systems in a network at the same time. These many machines, whether they're divided virtually or physically, interact with one another to complete a single task. Distributed applications commonly follow a client-server pattern. There's typically a front end that runs on a client computer and requires very little processing power, and a back end that runs on a server computer, which I hope is in the cloud, that has much more processing power. This model lends itself particularly well to a cloud computing architecture. If you want to know more about cloud computing, watch my other video, What is the Cloud? One cool benefit of distributed applications is that if one system goes down, other machines in the network can pick up the slack, so your entire system doesn't go down like it would if it were all being served from a single machine. This is called failing over. Okay, so virtualization is making one big computer seem like lots of smaller computers, and distributed applications are just like regular applications, but instead of one machine, they use many machines that can communicate to accomplish a single task. Okay, let's revisit that big definition one more time. An OS level virtualization method for deploying and running distributed applications without launching an entire VM for each application. Alright, what's a VM? So VM stands for virtual machine. This is a concept tightly related to virtualization, which we covered earlier. A virtual machine is something that mimics dedicated hardware so you can run a non-native operating system or application environment on a different type of machine. So I know that might sound confusing, but if you've ever run Windows on a Mac, probably using VMware Fusion, then you've used a virtual machine. Basically, your virtual machine is a wrapper that translates the Windows-specific instructions, which were meant for a Windows set of hardware, into a language that their Mac hardware can understand. Because there's this extra translation step, and you need a full copy of the other OS that you're stacking on top of your machine's native OS, VMs typically run a little slower than the real thing, but there's still a reason they were invented. It's because they reduce or eliminate the need for additional hardware when you want to run multiple machines. For example, if you want to run Windows and Mac OS, you could buy two separate machines, or you could buy just one and use a virtual machine to imitate the other. If your machine is powerful enough, you could even run multiple VMs to make it seem like you had, a Mac and 3 Windows machines. Okay, so why does that definition I read celebrate the fact that we don't need an entire VM for every application? I mean, virtualization and containerization are starting to sound a lot like the same thing. The fact that you don't need an entire VM for every application is actually a key concept in trying to understand the benefits that containers provide over virtual machines. So remember that each virtual machine gets a full copy of the operating system's kernel, which can amount to a huge amount of repeated information just clogging up your system's limited memory. In containerization, however, the containers share a copy of the OS's kernel, which leaves a lot more memory open for the stuff we're actually trying to do. Each container gets only the components it needs to run the application, while the operating system handles balancing between the containers so no one of them can hog up the CPU or memory. Okay, so here we've covered another key part of our definition, which was an OS level virtualization method. When we say OS level, we just mean that the operating system kernel is shared between containers rather than being repeated for each one. Alright, at this point we've broken down each of the confusing parts of our definition of containerization. Since Docker is a containerization platform, if you've understood up to this point, then you understand the basics of Docker. To piece it all together one more time, Docker is a containerization platform. Containerization is an OS level virtualization method for deploying and running distributed applications without launching an entire VM for each application. OS level just means that each container shares a copy of the OS kernel rather than copying it over and over. Virtualization is when we divide up our resources logically rather than relying on many different physical machines. A distributed application is one that uses many systems that can communicate with each other to accomplish a single task rather than a single system. And one main reason to use containerization over virtual machines is the increased efficiency we get from sharing a copy of the OS kernel instead of repeating it over and over again. Okay, so no discussion of Docker would be complete without covering some of the downsides of containerization. So I found a great article called The 5 Cons of Container Technology, and I want to point out a few of the drawbacks that it highlights. The first one is weaker isolation. So because they share an OS kernel, containers are not quite as isolated from one another as virtual machines. This means a successful attack on one container is much more likely to make its way down to the OS and spread to other containers than it would be to spread from virtual machine to virtual machine. Another thing to keep in mind here is that containers tend to have pretty deep authorization just to be able to run, so a compromised container can be scarier than a compromised VM. Another drawback they point out is the possibility of runaway compute power. I don't see this as a huge risk if you're being careful when you set up your architecture, but it's still worth pointing out. So one of the great things about containers is that they can be spun up and duplicated at an astounding rate. However, if you're not making sure they're spinning down when it's appropriate, you could end up paying for a whole lot of unused compute power. The last downside to containerization I want to point out are the limited tools that are available today. So just like in the early days of VMs, the early days of modern containerization have seen a disappointing lack of tools for monitoring and managing your containers. For an example of something that's going right, take a look at Google's open source project Kubernetes, which is a container management tool compatible with Docker. Thanks for watching. I hope this video has helped you to build an understanding of what Docker and containerization are. If you still have questions, let me know in a comment below, and thanks for watching.